Let's explore an interesting pattern in derivatives. Given the function y equals 1 over x, or x to the negative 1 power, we want to find the nth derivative and show that it equals negative 1 to the n times n factorial, all over x to the n plus 1 power. Let's solve this step by step. We start with our original function, y equals x to the negative 1 power. Taking the first derivative using the power rule, we multiply by negative 1 and reduce the power by 1, giving us negative 1 times x to the negative 2. For the second derivative, we apply the power rule again. We multiply by negative 2 and reduce the power by 1. This gives us negative 1 times negative 2 times x to the negative 3. We can rewrite this as negative 1 squared times 2 factorial times x to the negative 3. Let's find the third derivative. Following the same pattern, we multiply by negative 3 and reduce the power again. This gives us negative 1 times negative 2 times negative 3 times x to the negative 4. We can write this as negative 1 cubed times 3 factorial times x to the negative 4. Do you see the pattern forming? Let's highlight what's happening. First, the power of negative 1 increases with each derivative. Second, we're getting the factorial of the derivative number. And third, the power of x is becoming more negative by 1 each time. Therefore, for the nth derivative, we can write our general formula. Y sub n equals negative 1 to the n power times n factorial times x to the negative n plus 1 power, which we can also write as negative 1 to the n times n factorial over x to the n plus 1 power. This is a beautiful example of how mathematical patterns can help us find a general formula for the nth derivative. By observing the pattern in the first few derivatives, we were able to deduce the formula for any derivative number.